Okay, I don't know if you've heard this before, but some people claim that red and black inks are electrically charged in a way that makes them repel each other. Consequently, the longer you mix an equal number of red and black cards, they actually tend to separate from each other. Okay, so we're going to conduct a little experiment here where you're making all of the important choices in an effort to mix these well enough that the reds and blacks actually do separate from each other. Okay, so as you can see, I have a good selection of card values, suits, and colors. Now, I was careful to choose a total of 8 red and 8 black cards, okay, for the experiment here. Okay, so let's go ahead and close this up. Now, you could have 1 or 2 spectators for this. I'm going to assume that we have 2 spectators, a spectator A and a spectator B, and each of them are going to make independent choices mixing this packet, okay? And I just figured that would give us a better chance of a genuinely randomized packet of cards. Okay, so spectator A, your option here to begin with, we'll give you many options, is to have the cards dealt into 2 piles with random stacking decided by you. How would you like the piles stacked? Left on right? Okay. Would you like to perform any more of those? Just one more? Okay, that's fine. So left, right. How would you like the piles stacked this time? Left on right or right on left? You want left on right this time? That's fine. Okay, spectator B, your turn. I'm going to deal out into 4 piles with random stacking of the rows and then the piles that result from that. So how many of those would you like? Just 1. Okay. But just know that we could do it as many times as you like. And a note to you as the performer, that's true. You can deal out these cards into 2 piles like I just did a moment ago as many times as the spectator calls for, or into 4 in this way. And the spectators can truly dictate that. Okay, so spectator B, do you want top row on bottom or vice versa? You want bottom on top. How would you like the pile stacked? Left on right. Okay, so I think you said just 1 of those. Now at this point, we're going to deal out the cards into 2 piles. And then spectator A, you can choose which pile will be designated as yours. You want the one on the right. Okay, so spectator A, that's yours. Spectator B, that's your pile. Now, considering how well mixed the cards were at the beginning, you actually saw them displayed. I would think both of these piles are quite well mixed, but we're going to mix them further if you would like to. So spectator A, I thought we would perform a wonderful mixing procedure for really any packet of cards. It's called the Klondike Shuffle. Would you like me to perform it on yours? You would. How many times? Twice. Okay, so this is how the Klondike Shuffle goes. You take the top and bottom cards off as 1, okay? And I believe you asked for it being done twice. A note to you as the performer, the spectator can ask for any number that they like. They truly can. Spectator B, how many of these Klondikes would you like performed on yours? Just 1? Okay, you just like things done once, I guess, which is fine. Okay, so we did it once on yours. And then finally, we're going to perform really what is one of the most disruptive and destructive systematic mixing procedures ever invented. It's called the Australian Down Under. Okay, so spectator A, how many times would you like it performed on yours? Just once. Okay, so this is how it goes. You go down, under, down, under, down, under. Under. Sorry about that. Last one on top. We actually saw one of the cards. Sorry about that. And then what about spectator B? How many times? Twice. Okay. Down, under, down, under. I'll try not to drop the cards this time. Under. Last one on top. I think you asked for twice. Oh, that's refreshing. You actually asked for something to be done more than once. Okay. We're really having a great time here, dropping everything. I need to focus my 3 brain cells there. And last one on top. Okay. And then at this point, I'm going to give you each a whole bunch of choices that really will kind of seal the deal and what 2 piles of 4 cards each you'll have. Okay, so spectator A, I just dealt out the cards into 2 rows. So here are 4 options that you can choose from that lead to very different outcomes. We're going to switch 2 of your cards here on the top row with 2 down here. So we can switch the outer 2, we can switch the inner 2, we can switch the diagonal outer cards, or we can switch the inner diagonal cards. What would you like? You just want the inner 2 switched? Okay, so these would come down here. I'm going to go like that, and then we're just going to bring those together. So that's one pile of 4 that we'll take a look at in a moment. Here's your other pile of 4. Okay, spectator B, you're given a similar choice. You get four options here. Okay, so do you want the outer one switched, the inner, the outer diagonal, or the inner diagonal? You want the outer diagonal. Okay, so this is how that would work. That would go there. These would switch and go there. You just bring those together. These come together. Okay, so now we have 4 piles of 4 cards each. So spectator B, spectator A. Okay. Well, how did we do? Did we succeed in separating the reds from the blacks? Did we mix them well enough for that to happen? So spectator A, how did you do? Oh, you did not separate the reds from the blacks. I'm sorry to say. Okay, so yeah, this is not looking good for spectator A. Okay, what about spectator B? How did we do here? You did not separate reds from blacks at all. Neither one of you did. Okay, so it's either that we didn't mix the cards well enough, or this belief that's out there about mixing the cards thoroughly will inevitably separate reds from blacks may not be true. Okay, what's that? Oh yeah, you're right. Yeah. Spectator A is pointing out this piece of paper here. That's right. I do have a kind of written prediction for what I thought would happen here. So, separating reds from blacks. Well, we kind of failed that. Neither spectator will separate reds from blacks. Well, that's true. I don't know how surprising that prediction is. Both of you guys failed. In fact, I'd be surprised if you succeeded, actually. Oh, wait, okay. But instead what? Both spectators will separate face cards from number cards, since face cards have far more ink on them. Okay. I didn't even think about the fact that having face cards in here could throw off the whole experiment, and my prediction suggests that it would. So we didn't separate reds from blacks, but did we in fact separate number cards from face cards? Because face cards have more ink. We did here, and we did here as well. Okay, whoa, how did we do that? How could that written prediction have predicted our failure of separating the reds from the blacks, but our success in separating the face cards from the number cards? Okay, so how does this work? Well, once I show you how to set up the packet, you just do everything that I did, and this works perfectly. So all you need is a 4 red face cards and 4 black face cards, and you just mix them really well. Okay. And then 4 red number cards mixed in really well with 4 black number cards. So this is where I started. The setup for this takes, I don't know, 90 seconds maybe. Okay, so you have these 2 packets. So I didn't, those aren't very well mixed, are they? That was genius. So it's good to check these. So this is just the setup. So you have reds and blacks face cards, reds and blacks number cards, 4 of each. Now you can randomly stack these, and then all we need to do is use a wonderful, clever procedure by Warner Miller to convert this packet to what's called a Quasi-Bessey sequence of order 16. So you push off pairs into this triangle configuration like this, and then the first pile dealt, this one was the first pile to be created. You pick up that one first and stack in opposite order, and then one more quick step. You perform either a mange over-under or an under-over. Both work just fine. And then you are ready to go. So that's the kind of packet that I showed at the very beginning. And so if you need to kind of move number cards among themselves or face cards to make it look more random in terms of like color distribution, you can certainly do that. I mean, it's looking fairly good here in terms of color distribution, but technically this is a Quasi-Bessey sequence of order 16 relative to face cards and number cards. Okay, and then I also want to point out that when we separated them into a pile of 8 for each spectator, each of those individually are now Bessey sequences, which can be mixed in additional amazing ways, like the Klondike Shuffle, and not harm that organization. Okay, so all of this is talked about in the playlist down below. I'll have a playlist to Bessey sequences and Quasi-Bessey sequences, as well as a list of applications of these amazing packet structures that allow you to mix the cards in literally hundreds of different ways and not lose track of the underlying structure of the cards. Okay, well, thank you for watching, and take a look at other videos on the Absolute Math Magic channel.